Good day, everyone. I'm Moldes Allen again. I'm going to present some Java language issues, including Eclipse IDE, version control, and Subversion, or the SPN. Eclipse IDE. In the context of computing, Eclipse is an integrated development environment for developing applications using the Java programming language and the other programming languages such as C++, Python, Perl, Ruby, etc. Eclipse is an integrated development environment used in computer programming. It contains a base workspace and an extensible plugin system for customizing the environment. Eclipse is written mostly in Java and its primary use for developing Java applications, but it may also be used to develop applications in other programming languages via plugins. The Eclipse platform provides the foundation for the Eclipse IDE is composed of plugins and is designed to be extensible using additional plugins. Developed using Java, the Eclipse platform can be used to develop rich client applications, integrated development environments, and other tools. Eclipse can be used as an IDE for any programming languages for which a plugin is available. Eclipse Software Development Kit, or the SDK, is a free and open source software released under the terms of the Eclipse public license, although it is incompatible with the GNU or the General Public License. It, it was one of the first IDEs to run under the GNU class path, and it runs without problems under IST. The Java Development Tools of the JDK projects provides a plugin that allows Eclipse to be used as Java IDE. pdev is a plugin that allows Eclipse to be used as a Python IDE, C++ development tools. CDT is a plugin that allows Eclipse to be used for developing application using C++. The Eclipse Scala plugin allows Eclipse to be used as an IDE to develop Scala application, and PHP Eclipse is a plugin to Eclipse that provides complete development tool for PHP. The initial code base originated from IBM Visual Edge. The Eclipse Software Development Kit, which includes the Java development tools, is meant for Java developers. Users can extend its abilities by installing plugins written for the Eclipse platform, such as development toolkits for the other programming languages, and can write and contribute their own plugin modules. Since the introduction of the OSGI implementation in version 3 of the Eclipse, plugins can be plug stop dynamically and term bandies. The history of the Eclipse was inspired by a Smalltalk-based Visual Age family of integrated development environment products. Although fairly successful, a major drawback of the Visual Age products was developed code was not in a component-based software engineering model. Instead, all codes for a project was held in a compressed lump, somewhat like a zip file but in a proprietary format called .dat. Individual classes could not be easily accessed, certainly not outside the tool. A team primarily at the IBM Carey NC Lab developed the new product as a Java-based replacement. In November 2001, a consortium was formed with a board of stewards to further the development of Eclipse, such as open source software. It is estimated that IBM had already invested nearly $40 million by that time. The original members were the Borland, the IBM, Marant, the QNX Software Systems, Rational Software, Red Hat, the SUSE, TogetherSoft, and the WebGame. The numbers of stewards increased to over 80 by the end of 2003. In January 2004, the Eclipse Foundation was created. Eclipse 3.0 released on June 21, 2004, selected the OSGI service platform specification as the runtime architecture. Licensing. The Eclipse Public License or the EPL is a fundamental license under which Eclipse projects are released. Some projects require dual licensing, for which the Eclipse contributions license is available, although use of this license may be applied for and is considered on case-by-case basis. Eclipse platform and other plugins from the Eclipse Foundation is released under the Eclipse public license. EPL ensures that the Eclipse is a pre-download and install. Also, Eclipse to be modified and distributed. Eclipse was originally released under a common public license, but was later licensed under the Eclipse public license. The Free Software Foundation has said the both license are free software license but incompatible with the GNU or the General Public License. The name, the Eclipse IDE, according to the Linachman Chief Technology Officer of the IBM Rational Division, that was originated by 2003. At that time, the name Eclipse, dating from at least 2001, was not a wordplay on Sun Microsystem, as the product primary competition at the time of naming was Microsoft Visual Studio, which Eclipse was to Eclipse. Different versions of Eclipse have been given different science-related names. The version named after the Callisto, Europa, and the Ganymede, which are moons of Jupiter's, were followed by a version named after Galileo and discoverer of those moons. These were followed by the two sun-themed names, Helios of Greek mythology and Indigo, one of the seven colors of the rainbow, which is produced by the sun. The version after that, the Juno, has a triple meaning: a Roman mythological figure, an asteroid, and a spacecraft to Jupiter. Kepler, Luna, and Mars continue the astronomy theme, and the neon, the oxygens, constituted a theme of chemical elements. Photon represented a return to some themed name. As of 2018, the alphabetic scheme was abandoned in order to better align with the new simultaneous release strategy. Releases are named in the format a year, month, to reflect the quarterly release, starting with the version 4.9 named 2018-09. These were the releases of the Eclipse IDE every year since 2006. The Eclipse Foundation releases the Eclipse platform and a number of the other plugins in June. From 2008 through 2018, each simultaneous release had occurred on the fourth Wednesday of the June. In 2018, the project switched to quarterly, or it was a 13 weeks with the year and month releases without immediate service releases. In architecture of the Eclipse IDE, the Eclipse SDK includes the Eclipse Java Development Tools, or the JDT, offering an IDE with a built-in Java incremental compiler and a full model of Java source files. This allows for advanced refactoring techniques and code analysis. The IDE also makes use of workspace, in this case, a set of metadata over a flat file space, allowing external file modification as long as the corresponding workspace resource is refreshed afterward. Eclipse uses plugins to provide all the functionality with on the top of the runtime system. It Its runtime system is based on Equinox, an implementation of the OSGI core framework specification. In addition to allowing the Eclipse platform be extended using the other programming languages such as C and Python, the plugin framework allows the Eclipse platform to work by typesetting languages like LaTeX and networking applications such as Telnet and database management system. The plugin in the architecture supports writing any desired extensions to the environment such as for the configuration management. Java and the CBS support is provided in the Eclipse or in the SDK with support for the other version control systems provided by third-party plugins. Um, Eclipse implemented the graphical control elements of the Java toolkit called the standard widget toolkit or the SWT, whereas most Java applications use the Java standard abstract window toolkit or the AWT or SWI. Eclipse users interface also uses an intermediate graphical users interface called the JFace, which simplifies the construction of the application based on the SWT. Eclipse was made to run on a Wayland during the Google Summer Code project in 2014. With the exception of the small runtime kernel, everything in Eclipse is a plugin. Thus, every plugin developed integrates with the Eclipse in the same way as the other plugins. In this respect, all features created equal. Eclipse provides plugins for a wide variety of models. Example of plugins include for unified modeling languages or the UML for the sequence and the other UML diagrams, a plugin for DB Explorer, and many more. And as of 2017, language packs being developed by a Babel project provides a translation into over 40 natural languages. Rich Client Platform. Eclipse provides the Rich Client Platform RCP for developing general purposes. The following components constitute the Rich Client Platform: the Equinox OSGI, a standard bundling framework, or the core platform. It is a boot Eclipse run plugins, the standard widget toolkit, or the SWT, a portable widget toolkit, the JPace, viewer classes to bring model view, controller programming to SWT, file buffers, text handling, text editors, the Eclipse workbench, views that can view edits, perspective wizards. These were the example of the rich client application based on the Eclipse. These are the IBM Notes 8 and 9, the attachment novel or the net IQ designer for the identity manager, the Apache Directory Studio, the remote component environment, the dbeaver SQL client software, portfolio performance, UDIG, a GSIS software, AnyLogic, a multi-method simulation modeling tool. Moving for the version control. Version control, also known as the revision control, source control, or the source code management, is a class of a system responsible for managing changes to computer programs, documents, large websites, or the other collections of information. Version control is a component of a software configuring management. Version control changes are usually identified by a number of a letter code, termed the revision number, revision level, or simply the revision. For example, An initial set of files is a revision 1. When the first change is made, the resulting set is a revision 2, and so on. Each revision is associated with the timestamp and the person making the change. Revision can be compared, restored, and with some types of files merge. The version control is important to keep track of changes and keep every team member working of the latest version. You should use the version control software for all code files and assets that multiple team members will collaborate on. Version control system allows the multiple developers and designers team members to work together on the same project, also known as the BCS. These systems are critically to ensure everyone has access to the latest code. As development gets more complex, there's a bigger need to manage multiple versions of the entire product. The basic concepts, uh, version control, the tracking changes. Version control is the mostly based around one concept, tracking changes that happen within the directories or files depending on the version control system. This could vary from the knowing a file change to knowing that specific characters or bytes in a file have been changed. The repository, this is the set of files or the directories that are under version control. Um, Tracking changes. In most cases, you specify the directory or set files that should have their changes tracked by a version control. This can happen by checking out or cloning a repository from a host or by telling a software which of your files you wish to have under a version control. Or as you make changes, it will track each change behind the scenes. The process will be transparent to you to until they are ready to commit those changes. Committing. As you work with your files that are under version control, each change is tracked automatically. This include modifying a files, deleting a directory, adding a new file, moving files, or just about anything else that may alter the state of file instead of recording. Each change individually, the version control system will wait for you to submit your changes as a single collection of action. In version control, this collection of action is known as the commit. Mm. Revisions in change sets. When a commit is made, the change are recorded as change set and given a unique revision. This revision could be in the form of incremented numbers, sample 1, 2, 3, or a unique hash, depending on the system. By knowing the revision of change set, it makes easy to view or reference it later. A change set will include a reference to a person who made the commit. When the change was made, the files or directories affected, a comment, and even the changes that happen within the files or the lines of code. In revisions and change sets, when it becomes to collaboration, viewing past revisions and the change sets is valuable tool to see how your project has evolved and for reviewing teammates' code. Each version control system has a formatted way to view a complete history, even the logs of each revision and change set in a repository. Getting getting updates. As a members of your team, commit commit changes. It is important that you have the latest version. Having the latest version reduces the change of a conflict. Getting the latest changes from a repository is as simple as doing a pull or update from another computer, usually a hosted or centralized server. The diffing or the viewing of the differences, since each commit is recorded as a change to a file or a set of files and directories. It is sometimes useful to view what changed between revisions. For instance, if a recent deployment of your website is broken and you narrow down the cost of the particular files, the best action to take it to see what I recent change in that file. Branching and merging. Branch allows to create a copy or a snapshot of the repository that you can modify in the parallel without altering the main set. You can continue to commit new changes to the branch as you work, while others commit to the trunk or the master without the changes affecting each other. These were the types of the version control system. Number one is the centralized version control. These were the main concept of the centralized system. Is that it works in a client and server relationship. The primary benefits of a subversion are this is easy to understand. You have more control over the users and the access. More GUI and IDE clients, simple to get started. At the same time, Subversion has some drawbacks dependent on access to the server, hard to manage the server and backups. It can be slower because every command connects to the server. Branching and merging tools are difficult to use. Next is the distributed version control. The primary benefits of the GAT or the Mercurial are more powerful and detailed change tracking, which means less conflicts. No server necessarily. All actions accepted sharing repositories are the local or the commit offline. Branching and merging is more reliable and therefore used for more often. And it is fast. At the same time, GAT and Mercurial do have some drawbacks. The distributed model is harder to understand. It's new, so that as many GUI clients, the revision are not incremental numbers, which make them harder to reference. It can be easier to make mistakes until you are familiar with the model. Next is the subversion or the SBN. Um, Subversion is a open source community has used Subversion widely. For example, in a project such as Apache, Software Foundation, Pre-Pascal, Pre Pre-BSD or and SourceForge, and from 2006 to 2019, GCC, the Codeplex, was previously a common host for a Subversion repositories. Subversion is a software revisioning and revision control system distributed as an open source under the Apache Apache license. So software developers are use Subversion to maintain the current and the historical version of files such as source code, web pages, and documentation. Its goal is to be mostly compatible successor to the widely used of concurrent version system or the CVS. Subversion was created by CollabNet incorporated in 2000, in the year 2000, and is now a top-level Apache project being built and used by a global community and contributors. The history of the Subversion, CollabNet founded the Subversion projects in 2000 as an effort to write an open source version control system which operated much like CBS, but which fixed the bugs and supplied from some features missing in CBS. By 2001, Subversion had advanced sufficiently to host its own source code, and in February 2004, version 1.0 was released. In November 2009, Subversion was accepted into Apache Incubator. This marked the beginning of the process to become a standard top-level Apache project. It became a top-level Apache project on February 2010. Um, These were the release dates extracted from the Apache Subversions file, which records all the release history. The features of the Subversions commits a true atomic operation, rename or copied or move or remove files, retain full revision history, revisioning of symbolic links, native support for binary files with space-efficient binary diff storage, natively client-server layered library design, client-server protocol sends diffs in both directions, cost proportional to change size, not to data size, internationalized program messages, additional, the system maintains versioning of the directories, renames and file metadata, but not for the timestamps. Users can move or copy entire directory trees very quickly while retaining full revision history. Additional, it was a path-based authorization. Merge tracking, merges between the branches will be tracked. This allows automatically merging between the branches without telling the subversion what does and does not need to be merged. Another features, the change list to organize commits into a commit groups. Subversion offers two types of repository storage. Number one is the Berkeley DB, or the deprecated. The original development of the Subversion used the Berkeley DB package. Subversion has some limitation with the Berkeley DB usage when a program that accesses the database crashes or terminates forcibly. No data loss or corruption occurs, but the repository remains offline while Berkeley DB replaces the journal and cleanups any outstanding locks. Um, these were the safe way to use the subversion with the Berkeley DB repository involves a single server process running as one user. Instead, or through a shared file system, the the Berkeley DB backend was deprecated in version 1.8. The repository access, the FSFS, beginning the subversion 1.2, FSFS become the default data for store new repositories. The FSX, a new file system called FSX, is under development or remove some limitation of the FSFS version of 1.9 was not considered production ready. Next is the repository access. repository access. All three means can access both FS and Berkeley DB repository. These were the access to Subversion repositories can take place by file system or the network file system access by a client directory, or next the web dub or delta B using the mode dub SBN module. Next is the custom SBN protocol using plain text or over the TCP IP. This mode uses either the SPN for encrypted or transport, for tunneling over the SSH. The layers of the subversion. Internally, a subversion system comprises several libraries arranged as layers. Each performs a specific task and allow developers to create their own tools and that desired level for complexity and specificity. Um, FS is the lowest level. It implements the version file system which stores the user data. The repos concerned with the repository built up around the file system. Um, it has many helper functions and handles the various hooks that a repository may have. Example as the scripts that run when the action is performed. Together, the FS and the repos constitute the file system interface. The RA handles or the repository access, both local and remote. From this point, repositories are referred to using URLs. The client, WC, these were the highest level and it abstract repository access and provide common client tasks such as authenticating users or comparing versions. Subversion clients use the WC library to manage the local working copy. Um, so these were the file system of the Subversion. The Subversion file system uses transaction to keep changes atomic. A transaction operates on a specific revision on a file system, not necessarily the latest, but the transaction has its own route on which changes are made, and it is then either committed and becomes a later revision, or or is or it is aborted. The transaction is actually a long-lived file system object. A client does not need to commit or abort a transaction itself. Rather, it can also begin a transaction, exit, and it can be reopen the transaction and continue using it. Potentially, multiple clients can access the same transaction and work together on an atomic change through no existing client expose this capability. In the file system, one can view the subversion files as two-dimensional. Two coordinates are used to unambiguously address file system items. The path or the regular path of the OS Unix like an operating system, file system, the revision. Each revision is a version file system has its own root, which is used to access the contents, and that revision files are stored as links to the most recent change. Thus, a subversion repository is a quite compact. The system consumes storage space proportional to the number of changes made, not to the number of revisions. The properties of the subversion, one important features of the subversion file system is properties. Simple, the name equals to value, pairs of text. Most properties occurs on the file system entries. Examples are the files and the directories. These were the version like other changes to the file system. The Subversion client reserves the SBN prefix for the built-in properties, but the other names can be used to define a custom properties. branching and tagging for the subversion. Subversion uses the interfile branching model from perforce to implement branches and tagging. A branch is a separate line of development. Tagging refers to the labeling the repository at a certain point in time so that it can be easily found in the future. In Subversion, the only difference between the branches and tags is how they are used. In branching and tagging, all the version in each branch maintain the history of the file up to the point of the copy plus any changes made since one can merge changes back into the trunk between the branches. A new branch of tag is set up by using the sbn copy command, which should be used in the place of the native operating system mechanism. The copy directory is linked to the original in the repository to preserve its history, and the copy takes very little extra space in the repository. Next is the subversion tags and branches. This history to space projection has a multiple issue. Number one is when a snapshot is taken, the system does not assign any special meaning to the name of the tag or the snapshots. This is difference between a copy and a reference. The revision is recorded and the snapshot can be accessed by URL. Uh, this makes some operations less convenient and others impossible. Next is when two or the ideally independent object types lives in a repository tree, fight to the top can assure. In other words, it is often difficult to decide at which level to create the tags in the subdirectory. Um, the revision numbers are difficult to remember in any version control system. For this reason, most of the system offers symbolic tags as user-friendly reference to them. Subversion does not have features, and what is documentation recommends to use instead is very different in nature. Instead of implementing tags as references to points in history, Subversion recommends making snapshot copies into well-known subdirectory in the space of the repository tree. Only a few predefined references are available. These were the head, the base, or the prep, and committed. To address such issues, posters on the Subversion mailing lists have suggested a new features called the labels or the aliases. SBN labels more closely resemble the tags or the system, such as the CBS or the Git, the GIT. The fact that the Subversion has global revision numbers opens the way to a very simple label revision implementation, yet in 2013, no progress has been made, and symbolic tags are not in the list of the most wanted features. This will be the end of my reports. For some references, these are the references that I been used. Thank you for listening.